All right, hi everyone. Let's get started. Today we are going to talk about personally one of my favorite packages of all time, Pandas. So what we're going to do is kind of look at how we can access, store, and look through real world data, because we are now getting to the point where we want to be able to use files of a bunch of different types of data. And we've already learned how to plot. So to plot, you need data. So now we're going to look at how to, number one, access, but also organize and load in all of that data. And we're going to do that using Pandas. Announcements. I think a homework was due today. I cannot remember the number of what homework.
Are you talking about late deadline?
No, the actual deadline, I believe homework 6 was due before class today. And we will be releasing homework 7 very soon.
Also, make sure you guys fill out your project proposal. It's due on Monday.
Yes. So your final project proposal is due on Monday. So make sure you guys do work on that, because if you guys submit it, then we can give you feedback, and then you guys have the green light to get started. If you don't submit it, it's going to be hard for us to get you guys feedback in time for you guys to actually start and not procrastinate it, which will be good. Okay.
Also, in your requirement, process support.
Yeah.
So, and please take advantage of this, because this is very good for research, or odds, anything. Because no one will believe you if you just write simply put Python in the skills section. No one can do that. You have to have somebody who's a Python god. Anyone. So, yes. Instead of the thing on the resources that do November 3rd. Okay, then it's November 3rd. I don't know what to do.
Okay. It is due on November 3rd, but still, please get a head start. Start thinking of ideas, come up with fun, cool, creative things. And then you'll have a good time doing the project, which will be good. All right. So let's do a super little recap. So we've looked into NumPy. We looked at arrays. We looked at statistical functions like the NumPy min, NumPy max, NP0. So we've done all that stuff, and you guys will be exploring that through your homework even more. Here's the documentation for NumPy if anyone ever needs to use it. But basically, NumPy is our go-to package to do basically any kind of mathematical or statistical operation anytime we need to work with numbers. Also, we've explored functions, loops, plotting, which are all super crucial concepts. One good thing about this last segment of plotting and data, or using data, is it's going to kind of bring together everything we've learned, which will be really cool. So last week, this week, and next week, it's kind of a consolidation of using all these basic tools like lists, for loops, while loops, if and else statements. We're going to use all that with real things like plots and data and fun things like that. So we've looked at really simple, cute data. All the data I have given you guys to plot, you've had very straightforward data. But data in the real world is very different, because number one, there is a lot of it. Data is not 10 little points that you can put on a list. Usually it's hundreds, thousands, sometimes even millions of different individual data points. And to say the least, data is typically very messy. It's not going to come in a neat little table that has all these really cute headers that tell you exactly what the data is. They're not all going to be the same number of significant figures and all this stuff. Usually it's very messy because it's real time. It's real time observations, which are always prone to errors. Sometimes if you're taking measurements from a certain spacecraft or instrument like that, maybe the instrument malfunctioned that day, maybe the readings are weird. So you're going to have a lot of little errors and fluctuations in your data. So missing data points, sometimes your data tables don't have a structure, sometimes things are not standardized, or things are not all in the same system of units. There's so many potential problems with data. But what we want is to be able to actually take that messy data and clean it so we can use it and we can understand it. So I'm going to give you a little example. So this is data that I use for my research. If you look at it, so basically you don't need to understand any of what the data is, but in my data set, these are like all the different axes of my data. So my total data set contains 7,594 times 33 times 84 data points, which is like a crazy amount of data. But also it contains data on all these like variable axes, and each one of these variables has that 7,900, that 7,000 number times 33 times 84 amount of data. So like I'm working with tons of data. So if I'm just writing a for loop to go through all this data, my computer is going to hate me, like crash and run for like 3 days. Either run for 3 days or crash. So we need to learn how to effectively, number one, like tabularize your data, because looking at this, like, what am I going to get out of it? I'm just going to see that there's all these different variables in my data, but I don't know what any of them are. I don't know what values they hold. A lot of things like that. So now what we want to do is be able to take some real world data and like actually understand it. So the way we're going to start thinking about data, I want you all to open up the link. I posted it on Ed, so you guys don't need to like type it in. Let's open that link. And what we're going to do, I'll give you guys like a second to click on the link. But once you open it up, you'll see that this data is actually a survey about salaries that this website conducted called askamanager.com. So some observations from the data. So when you guys open up the site, which I will also do now on my laptop. Oh, okay. I was going to be like, did they get rid of my data source? Okay. Cool. So as it says, basically there was this survey sent out to a bunch of people. Also, anyone that visits this website can fill out the survey. But basically it's asking a bunch of questions, and then it like asks you what your salary is, and it tries to just collect data like that. So here is the actual survey, this Google form, but you can also view all the responses in a sortable spreadsheet, which is what I want you guys to open up. So that'll take you to this Google sheet. So immediately we see a lot more data than we're used to seeing so far in this class. In terms of like, there is a bunch of entries, a bunch of columns. Wow, my laptop's being a little slow, but there's a bunch of entries, a bunch of columns, and basically there are a bunch of answers to these questions that the survey has. And this is a lot of information, and it could be a lot of useful information, but we kind of can't really access that useful information because it's all thrown in this one huge giant table. We don't really know what to do with it. Yeah, so for some of the features, there's like a bunch of variables. The variables are all like these little column headers, so like job title, how old you are, so your age, what you're working in, what industry you're working in. 6 of the variables are freeform text entry, which means you can type in like anything you want. For example, this additional context question, people could type in whatever they want here. It's just freeform text. Same with, let me see. Yeah, same with like if your income needs additional context, or like, there's certain ones that aren't like, it's not like a bunch of options. You actually put in text. So for questions like that, it's going to be very difficult to like look at the data and make sense of it, because some people won't put data in there. Other people will, and it might be different text and stuff. Also, this is a live data set, which means if I were to fill out this form right now, it's going to be updated on this data set. So anytime that you like do an analysis of your data, you want to make sure that any analysis you do, anytime you add in new entries, you can still use the same system. Because every time someone adds in new data, you don't want to like rewrite a bunch of lines of code just to like access one more row of data. So overall, you want your analysis to be encompassing of your whole data set. So the first thing I'm going to have you guys do is like take a little minute or two, chit chat with the people around you, and come up with 3 ideas how of how like we can use this data. Like what information can we get from this data set? Like what are 3 questions, for example, that we can answer by looking at the data in this data set? Can be like as simple, like the questions don't have to be complicated, just like what kind of questions can you ask that this data can answer? So I'll give you guys a minute and then we'll reconvene.
Does having higher education result in average higher salary?
Yeah, you can also just be like, depending on how old are you, what type of job do you tend to do? The majority of people have in that.
Okay, cool. I heard some conversation, but does anyone have any like questions they came up with that they think this data could answer? Yeah.
What are based on age, how common are specific jobs?
Yeah, that's a good one. So based on like your age range, what is like the most maybe common job title, or what is the most common industry you work in? So that's one good question. Any other ones? Yeah, that's always super helpful because then you're like, oh, like, you know, you can kind of see like the average income that people in a certain age range are making, which is always really, really interesting. Anything else? I'll take one more. Yeah, that's also really good because a lot of times certain fields are going to require you to maybe have like a more advanced level degree or something like that. So by looking at, you know, information like how many, yeah, I'm pretty sure there's like how many years of professional experience or something you have, then you can see like what industries might require more experience and things like that. So those are all questions you can ask. Those are all really good questions you can ask. But the thing is now what we have to be able to do is kind of parse through all this like massive amount of data to actually be able to answer those questions. For example, let's say that we want to just look at like the age, like how old you are and what your like annual salary is to see that range. You don't need any of the other information in this table to do that. You just need those 2 columns, right? But like if I'm going through the whole table and reading all this information, it's going to take me forever to just get, you know, the information from those 2 columns. Instead, we want to like select those 2 columns maybe and just perform analysis on those 2 columns. Or maybe you see how all these age ranges are in like categories or groups. So like there's a range of 45 to 54, there's a range of 35 to 44. What if we want to combine all the data in those ranges together? So then you can look at like a comprehensive understanding of the data in those groups. Those are all things that you might want to do with data. And those are all things that we're going to learn how to do because it's very, very helpful to, number 1, be able to select data that you're interested in. Number 2, be able to group data that you're interested in. And we're going to learn how to do that with pandas. Cool. So the entire process of like, number 1, looking at data. Number 2, finding questions that you want to answer. And number 3, being able to actually answer those questions. It's called exploratory data analysis. And that's something that literally anyone that works with data does. Anytime you're working with real world usable data, you're doing exploratory data analysis. So we just walked through a little, we got a little idea of what that is. So far, we don't actually have the tools to use, view, organize data. So we're going to learn how to do that stuff now. We're going to use this package called Pandas. And it's a data analysis library that helps make data cleaning and analysis very convenient. A lot of the syntax is very in line with NumPy, so you can use a lot of NumPy functions in like your Pandas statements and vice versa, which is really, really good because that means they're like very compatible. You can use those packages together. Very slay. So there are 3 main like data structures that you're going to work with in Pandas. Oh my god. So there's 3 main things, and we're gonna like cover what, like we're gonna understand what each one is a little bit more once we actually start using pandas. The first main thing is the orders. Ignore 0, 1, 2, 3 here. But the first main thing I'm going to talk about is a data frame. A data frame is basically a data table. That's all it is. It's a table of data. And in pandas, it's called a data frame. So it has rows, it has columns. It's basically a data table. And then if you were to take one column of that data table, that would be a pandas series. So the terminology is a little bit different, but the ideas are the same. So a column or a row is a series. And then a data frame is a data table. And then you know how like at the top of your data table, you always have a really nice like row of labels. That's your index. So that's what your labels are. So there's the 3 main like data structure objects that exist in pandas, and most of the things we do are gonna use these 3 structures. We're mainly only gonna see data frames and series. You only use index sometimes, but these are the 3 main guys that we talk about in pandas. Cool. Now, the best way to learn how to do anything in pandas is to actually do things in pandas. So what I'm gonna have to have you guys do is number 1, open up your Jupyter environment and create a Jupyter notebook. And then, so do that, but also go into your terminal and pip install pandas the same way that we've been doing for all other packages. So I'll give you guys 2 minutes to do that. No. Pandas is all lowercase. So the command should be like pip install. Don't put it in Jupyter. This should go in your terminal. If you're on Apple, sometimes it's pip 3 install, I believe. Yeah. So pip install pandas, pip 3 install pandas. Yeah, or conda install pandas. One of those will work. And also while you guys are doing this, if anyone has any questions on anything I've covered so far, please feel free to let me know. What I'm also gonna have you do, once you're done with that, hopefully everyone was able to get the Titanic data CSV off of GitHub. Also make sure you have that in the same like, what's it called? Directory, thank you. The same directory as your notebook that you're creating. Sorry, my brain just blinked on that word. But yeah. Give you guys until 3:30 to get all of that done. Give us 1 second. Cool. Do people have Panda installed, pip installed? All right. Now let's go into our Jupyter environment and we're gonna do the same thing that we always do when we have to use packages. This week or in this lecture, we're going to use two main ones, NumPy. So we import NumPy as NP. And then Pandas, the alias you typically use is PD. So I run that. Okay, cool. Now both NumPy and Pandas exist. Oh, you know what I didn't do? I didn't add my little data file, even though I told everyone else to. So the first thing we're going to learn how to do is create a data frame, which is basically create a table. So there are, so you don't usually create your own data very often, but we should still know how to do it just because like it's a good thing to know how to do. A lot of times you're going to be using existing data. So like you're going to use like a Excel file or a CSV file or TXT file that has some information. So first we're going to learn how to create our own data table or data frame, but then we're going to go on to learn how to like read from an existing one. So first, the way that you can, so there's two main kind of types of ways you can create a data frame. Number one is just using arrays. So like, let's say you have a bunch of arrays of data, you can create a data frame using those arrays. So the way that you create a data frame using arrays, so I'm going to create a data frame. My data frame is going to be called DF1, data frame 1. So the syntax, you can always look up Pandas syntax. It's very, very well documented, very well documented, just like NumPy is. But basically, I can create, let's say I want to create a table that has 3 columns. And my columns are called A, B, and C. So let's say, I don't know, let's create an array that's going to hold my values of my 3 columns. Sorry, my syntax will probably be a little silly goofy, so bear with me if I get a bunch of errors. Somebody give me like 3 numbers. I don't know, 3 random numbers. Okay, 4, 5, 2. I don't know, another set. Let's do like 3, 6, 9. And let's do 1, 2, 3. So this is my data that I want inside my data frame. And you can also add this thing, add to the columns parameter to tell you like what these columns are. So in my case, I want my columns to be called A, B, and C. Cool. Now when I run this, I have this really slay data frame with ABC as my columns, and 4, 5, 2 is the first row, 3, 6, 9 is the second row, 1, 2, 3 is the third row. Does it make sense how we did that? Cool. Gonna be so real. We don't really ever really do this just because we don't usually write into like a blank data frame very often, but it's good to know. If you are creating a blank, yeah.
Sorry,
Oh yeah. Yeah, so you just put like a list of strings. Those are going to be your labels for your column name. So if you want to call them like cat, bat, and like rat or something, you could just do the same thing. Cool. So this is using arrays. What is more common when you're creating a data frame than using arrays is using a dictionary. Does anybody here remember like the way a dictionary is structured? Like what does a dictionary hold?
Words.
It can hold words, but more specifically, yeah. Exactly. So dictionaries hold these key value pairs, right? Which is very, very helpful because what you can do is basically make your key the name of your column and make your values all the values you want in there. So that's why dictionaries are a lot more helpful when we're creating like pandas arrays. So I'm going to create an array. Sorry, oh my God. I'm going to create a data frame using dictionaries now. So I'm going to call it df2. And we're going to open a new data frame. Oh, sorry. Before that, I need to actually create a dictionary. That's so silly of me. So I'm going to call this my data dictionary. And dictionaries are created using the little flower brackets, curly brackets. I don't know what you call them, but those guys. Let's say I want a dictionary that holds like, I don't know, a bunch of fruits. And what fruits do I want in my dictionary? I guess like apples, mangoes. Is that how you spell mangoes? I don't know. Thank you. Strawberries. Oh. Bananas. Bananas. All right, so let's say that that's one of my inputs into my data frame. And let's say I want one that stores vegetables. I don't know. I'm not being very original today. I'm sorry, guys. Broccoli, carrots, spinach. I guess that's a vegetable. I mean, it's a leaf more than a vegetable. But potatoes. Cool. So this is going to be my data frame. Sorry, this is going to be my data. So this is the data I want in a table. So I want a thing of fruits and a column of fruits and a column of vegetables to go in my dictionary. Oh my God, sorry, to go in my data frame. The two words both start with a D and it's like mixing up in my head. So now I have a dictionary of my data. I want to put that into an actual table. So what I'm going to do now, I created this data frame called data frame 2. I'm going to say that the data is basically data dictionary. Cool. And hopefully if I didn't type anything weird, yay! So now I have a table with all the fruits and the vegetables that I put into it. Does that process make sense to everyone? So you can create like key value pairings in a dictionary and just literally make your dictionary into a table. So you guys can see why this one's a lot more helpful than the arrays. Like it's already, your data's kind of already organized. So it's just it's much more intuitive to put it in a dictionary and then put it into a data frame from there. Cool. Hopefully that makes sense to everyone. Slide. Now we're gonna do, yes.
So it's like, it automatically places the key.
Yeah, so the key is automatically placed as the index label, yeah. Which is really, really helpful. Yeah, you don't need to like notice how here we had to separately say columns equals ABC to give them labels. Here I don't have to do that because fruits and vegetables are already taken in as indexes. Cool. Any other questions? Yeah.
What does the colon do?
Oh, so what the colon does when you create a dictionary, a colon separates a key and a value pair. So it's like, here's the key, here's are all the values under the key. So that's how dictionaries are like structured. That's how they usually are. So for example, in this one, my key is the string fruits. My value is the list of strings of fruits. Does that make sense? Because the key is fruits and then the value is my list. Yeah. Cool. Now we're going to do the most useful thing that Pandas has ever, actually no, Pandas is very useful in a lot of regards, but this is like the first step of using all those, being able to load in existing data. So hopefully everyone has the Titanic data CSV in their directory that this notebook is in. So all we have to do to actually load in a CSV file, I'm going to call this Titanic because it is Titanic data. T.read CSV. And all I have to do is put in the name of my file. I think this is what I named my file. So this is going to load in my data. So now when I return my data frame, wow, all of this data is now in Pandas as a table. Super straightforward. You can see why this is super, super useful. You can basically throw in any kind of data file that's already like tabularized and put it into a Pandas data frame. Quick question. Does anyone know what a CSV file is and why it's called CSV? Yeah.
The values are separated by.
Exactly. So comma separated value file. So the reason Pandas is able to parse CSV files so easily is because there's already something that's separating the values. So let's say you use like a text file or something, it might be a little bit more difficult for Pandas to understand that. But if you look at the Pandas documentation, when you are creating a data table, there's like usually like a delimiter parameter that you can set to like maybe if your data is separated by a space or by a period or something like that, you can set the delimiter to that and it will then be able to read your data. I hope that makes sense. I know that was a lot of words, but yeah. Cool. Now we know how to now we know how to get data onto Pandas. So now we can start learning how to sort, index, use this data. Cool. So let me go back to my slide super quick and make sure I'm actually going the right order of things. Okay, cool. So what we just did in the demo, we looked at creating data from scratch, not something we usually do. We looked at how to create data from a dictionary, which we now know how to do. Also loading up from an existing data source, like the CSV file that we just loaded in. Now what we're gonna do is learn how to select our data. By select our data, let's say I want a certain row or a certain column of data, being able to just isolate those certain rows or columns. Is what we're going to learn how to do. So I'll do like a quick talk through it, but it'll make a lot more sense when we actually continue on with the demo. So cool. So there are two main ways. Oh, you guys can't, how do I? Perfect. So there are two main ways to access or to slice your data tables. They're lock and iLock. So these are the two methods you use. Lock, it starts with an L, so that's label based. So basically, you can take the name of your, like the column name, and you can access that column by using that name or row, whichever way it works. So in this little table here, hopefully, can people see that at the back? I don't know. But basically I have like my columns are called max speed and shield, and my rows are called Cobra, Viper, and Sidewinder. I don't know what these are, snakes, I guess. Oh, never mind. Yeah. So if I call df.lock of Viper, it's gonna be able to return it's gonna return the item 6 and 5. So it's by the label. Now, for example, if I were to call df.lock shield, can someone tell me what that would return? Exactly, 358, because it's going to return this column of data called shield. Does that make sense to everyone? So it's basically based on the label, yeah.
So when you're referring to a row and a column, it is done in the same way, right? Or it's the same? Or one's calling for the name of the row and one's calling for the name of the column?
Okay, so typically your rows and columns, well, ideally, your rows and columns should not have the same labels, because your columns will likely have numerical labels. Sorry, your rows will likely have numerical labels. You'll go row 0, row 1, row 2, so on and so forth. And then your columns will usually have string labels, because like that's what your data is. So when you call like df.lock on like a number label, it's going to typically know it's a row, and when it's a string, it's going to know it's a column.
In
But
the first example, it's knowing Viper is.
yeah, so it
is
knows
row
Viper is a
because
row,
It is.
not a
on that
column.
side.
Yeah.
And if Viper was a row and a column, it would just do an error.
I'm assuming if Viper was a row and a column, it would return the row. So the way that we're gonna look at this in a little bit, but you can also index by both row and column. And when you do that, you put like the row first and then the column.
Okay.
Does that make sense? Okay, cool. So that's lock. So that lock is label based. There's also something called ilock. So ilock is integer indexing. Sometimes like if like I kind of only use ilock when sometimes like my labels for certain columns are really, really long strings of text and I don't want to type them. So in cases like that, you want to use the actual index of the column or the row instead of using the string title or the label. In that case, you can call .ilock, and that will give you whatever data is at that index. Does that make sense? Does the difference between the two make sense? .lock and .ilock. And we're gonna do like an example, so don't be too stressed if, yeah.
So if the index was numbers, the first one would still work though. Like you could still use the normal lock if you had your index is going from 0 to whatever. A different index of
Yes.
numbers, it would
Yes.
be in a string versus in a
Yes.
number.
Exactly.
Okay.
So yeah, it should still work. Correct. Sometimes it doesn't work and you kind of just try the other one. Sometimes Python's weird. It's that kind of spiel with it. But overall, that's the idea. Lock is using label. ilock is using the integer index of those columns or rows. Cool. All right. Haha, this is part of my demo. Now, let's go back to this guy and let's actually use .lock and .ilock. Someone tell me what the most interesting column of this data frame is to them.
Index.
Like this one? Okay. All right. I mean, okay. So if, yeah, it just because like it doesn't have a column label. Cool. All right, age. Cool. So let's do age. Can anyone tell me using label-based indexing what they would type in to get the age column? Mm-hmm.
That one single apostrophe.
Mm-hmm.
Age.
Perfect.
And I hit the enter button.
Yeah. Wow, that's taking a hot sec to run. I don't know why. Was there an error? Ah, he errors age. What? Hold up. No. Mm-mm. What am I doing? What is going on? Am I forgetting how to? Let me just try something. Let me try something super quick. Okay, so lock 4 is.
Don't need it.
Hold up. No, you definitely need the apostrophe. Okay, well, lock 4, if I do this, it's gonna give me the 4th row of my data. So I know it's working. Okay, I know it's working. I know what's going on now. Okay. So basically what happened in lock, I should have been clear about this. Okay, so you apparently have to put in a row and a column no matter what, because otherwise it'll just default to being like that's the row and there's no age row. So it's like, what's going on? the way that you tell Python to do like all of the rows is by putting a colon. Colon? That's a colon, right? Yeah. So this is basically saying all of the rows at the age column. Does that make sense? Cool. So the default is assuming it's a row. So that answers your question. Yeah. Sometimes I forget how to do things. But learning experience. Okay. So this is how you would get columns, and then if you want a row, you can just put in like lock. Let's say I want row like 43. So that's going to give me whatever data is in 43 about this passenger.
You don't need to have a comma and then the colon.
No, you don't need to do that because it's going to assume that you want all the columns. But now let's say I just want the name of the passenger of the 43rd row. Here I could put in name, and it would just give me that one entry. So this is the name of the passenger in the 43rd row of data. Does that make sense to people? Yeah. So that is what lock does. Cool.
Like linear algebra kind of,
Well, I mean, not
right? Like you're like.
sort of, yeah.
IJ,
It's IJ, yeah, exactly. Except, yeah, it is if you're working with 2D data like this, which is really cool in Sly. Yeah.
So in that snakes and shields example, we can put lock of snakes.
Sorry, I can't look through tabs. Yeah, so here we would have had to do colon comma shield. Yeah, cool. And then ilog is going to work very similarly, but it's going to work with indexes, which doesn't really change much for rows. So let's say, I think if I do 2. Oh shoot, I forgot to put dot lock. This isn't going to like me. Yeah, so it works the same in terms of rows. So .ilock2 is going to give me the second row. And then if I do .ilock with the colon and then column number, so this is going to be my second column, and it's going to tell me the name of that column is passenger class. If we look up at our data frame, that is the name of the second column because we zero index. Does that make sense? Yeah.
So in the bottom of the output,
Mhm.
it says the data type.
Yeah.
What does it do if there's multiple different?
Ooh. So typically you're not going to have multiple data types within one column.
Well, like the age one has NaN.
Oh, okay. So NaN, basically, so no, NaN actually is, so a NaN value basically is not a number. It's a little confusing. So usually NaN values happen when number one, there's a missing data point. So that is not like, so let's say that, what column is that? That's on our age column. So let's say if I was to dot lock of this in age, it's going to give me that age has the data type of float because NaN values, those are not strings. NaN is like a type of value. And that's basically what you use when there's missing data. Does that make sense? It's kind of like a placeholder.
So can that be in any data type or specifically?
So technically in this case, if you were to replace this NaN value, you would have to replace it with an integer because you know the rest of your data is integers. So it's like contextual.
You mean float?
Sorry, floats. Yes, floats. Does that make sense?
Would NaN be put into place if it was like a string and there wasn't a thing? Because it stands for not a number, but it's
I actually don't know. I don't know. I've never seen NaNs in non-numerical data. I've actually just never, like NaNs in general just usually show up. But again, I don't really work with a lot of like string data, so maybe that's like a overall. I feel like for strings, it's typically just going to be an empty string. But I could be so wrong on that count. Overall, though, you see NaN when the number is either missing or it's like a weird value or like there was no actual data recorded at that point. And the one really cool thing about Python or Pandas, it'll actually let you like replace those NaN values, which is something that we will talk about in discussion. But think of it as just like a placeholder value for like something that doesn't actually, you can't actually, maybe there's like data that went wrong. So typically you don't want NaN values, but unfortunately data usually has a lot of NaN values.
So if it was like something that was like an input response from a person,
Mhm.
would it try and, what would it automatically try and detect as the data type? Would it do it as a string?
Yes, it would do it as a string. So like, let's say here, like passenger name, if I did this, it's gonna detect this as strings. Oh, interesting. Objects. Fun. I don't know. Sometimes Python doesn't do what I think it'll do. But okay, apparently this one has a data type of object. But let's see. In this guy, in this dictionary that we put in, if I were to, let's see what this does. df2, what is this at? Guess I'll do like, what's going on? It's fun. Okay, interesting. For some reason, it reads strings as objects as their data type. I guess that's just how Pandas parses it. Yeah. Megan, do you have like, do you know why? I don't know.
If it's a string, is it automatically interpreted as?
Yeah, I think strings are just taken to be data type object.
I think anything that's not.
I think anything that's not like a float or an integer must probably just default to object.
Yeah.
Yeah. Cool. I think that's it. So that's it for basic overview of how to access rows, columns, and things like that in Pandas. When we go into discussion on Wednesday, we're gonna do a lot more of actually like explore a lot more of what Pandas has to offer in terms of actually being able to go through the data and see it. But with the tools you have now, like for example, you can make like a plot, for example, of just like, I don't know, let's say I wanted to see like the ages of all the people on the Titanic. I could do that, which is really cool. I do have to import it. Yeah. Oh yeah, that's also something that's really slight with Pandas. It works really well with Matplotlib and Seaborn, especially Seaborn. So it is fun times. So now if you have data tables, you can kind of just be like, you can plot them, which is fun. I don't know if this will work. I hope it does, but if it doesn't, oh yeah, cool. So these are the ages of all the people on this Titanic. I guess you didn't want to plot that. Maybe scatter that. It needs a Y value. Cool. Oh, also, yeah, to get like those index values, like the 0 to 800 or whatever, you just do .index. And that gives you the index values. But yeah, these are apparently the ages of all the people on the Titanic on the y-axis. I didn't put labels on there. But Pandas works really well with plotting, which is why the age is on the y-axis.
I know.
Oh, yeah.
I was just like, it's sad that they didn't live to 800.
Yeah. Cool. That's it for today. If there's any